Hello guys, welcome back. So now we're going to set up the more complex constraint network. And in the first video when we did the wall, we set up the glue first and then the pin constraint, which gave us the soft behavior. Now what we need to do is we need a way to mix in these two behaviors, these two components together. And the best way I found to do this is to set up pin constraint. Let's go back here. So let's say we have these pieces together. I want to set up a glue constraint that groups this cluster basically, and then in between this cluster I want to set up a pin constraint, so those pieces can behave as a packed, dense, clustered unit, and then these clusters are connected with pin constraint in between them. So for example, when the sphere hits, it will all this block, for example, will be a cluster, a glue constraint and cluster together, and then the in between is a pin constraint. So we'll get breaking here, and then we'll get the soft behavior, and this gives the best combination to get the soft bending behavior of either it's a metal or a concrete. It depends. We have to control how much pin constraint versus a glue constraint we have, and that that controls the behavior of the mesh. But it has a very natural look to it. So let's see how we're going to do this. With the connect adjacent node, there's another one called glue cluster. What it does is, the idea for this node is to change the strength of this glue so that some pieces get very strong clustering, and then the connection between these clusters is very weak. And so the internal strength right now is set to -1, means never break, and then the cluster to cluster is set to 1. What I'm going to do is I'm going to isolate the inner clusters and set them to be a glue constraint, and the in-between clusters I'm going to set them to a pin constraint. And again, this is my own R&D, this is my own idea. If you have any other ways of creating interesting combinations or having multiple constraints together, please feel free to explore that. I'm pretty sure there is other ways to do this. So what I'm going to do is I'm going to isolate based on the strength. So if the strength is equal to -1, and it's a primitive attribute, so I'm going to change this to primitive. Let's say delete non-selected at strength equal to strength. Yes. So if the strength is should be just equal. Yeah, is equal to -1. I want to delete those guys, and then I'm going to do the inverse. So actually, let's use a split node to make it easier. So at strength is equal to -1. This is the primitive, and no space. And then this will be the first input here, and then the other input will be, the other result will be in the second input. Cool. So you can see now we have very few pin constraints. These are the guys I'm going to use as a pin constraint. So I want to tweak this cluster, so this clustering to have better distribution. I want to see the separation of the clusters much better. So let's increase the size. Okay, and let's turn off the jittering. I don't want any jittering at the moment. So see here, the color is pretty distinguishable. And let's take a look. These are actually the clusters, and this is the in-between connection. So these are the cluster that we're going to use as a glue constraint. Something like that. And then everything else is going to be a pin constraint. Okay, so let's add some jittering back to break this up. Cool. And this is going to be our glue constraint. So the at name and everything, this is going to be our glue constraint. And the other part is going to be a pin constraint. I'm going to call this just pin. And let's merge them together. And the last thing that we have to do is, we know the pin constraint is needs the 2 points of the primitive to be on top of each other. So I'm going to use a facet node, unique points, and then I'm going to use a primitive and scale everything so it's at 0, 0, 0. So if we scale this down, you see we get a point. Now the amount of the pin and the glue defines a lot of the behavior of this of what's going to happen to the sim. So let's dive back in and let's copy this node. Let's merge them here. And right now the pin is not going to break, sorry, because it doesn't have any breaking rule. So I'm going to set this to 0, and then this is going to be pin. And let's visualize the connection. We should see both now. Yeah, you see it. You see the cluster here? That's a glue. In between is a pin constraint. So this is hopefully going to give us something much better and has more connectivity, because the glue constraint does not propagate see, now we're getting this very nice bending, and it's resisting as well. So it's actually gonna go back and forth probably. And it's sliding here. Okay, let's go back. Maybe let's lower the strength. Oh, one more very important attribute. This any attribute that you declare, if it has a name that maps to it somewhere in any of these parameters, the SOP attribute will be used as the main input, and then the dot will be a multiplier. So we have to clean this up. We have to delete those extra attributes, make sure that it's not overriding anything. So here I'm going to delete the, let's see, the strength, propagate iteration, because that's in the glue as well, and I don't need the color. I'm going to remove that. And that's why the glue constraint was not breaking at all. And the pin constraint is much better at transferring the energy between the various blocks. And you can see now it has the soft behavior. And a lot of one very important aspect of doing a realistic sim is, even with walls, even with concrete, you get that nice bending before anything breaks, even with a very dense material, and this is going to give you that behavior. So only the glue is going to constrain. The pin is going to hold everything together. It's probably going to bend. It can bend and stuff like that. And this is another great way of doing rebar. If you want to convert those pin constraints to actual geometry, you can do that, but we just have to transform them. And this can look very realistic, because it's going to keep bending the geometry. Let's hit escape. Cool. So the last thing that we have to actually, I want to wait for this and see what's going to happen. The last few things we're not too far off from finishing this. It's starting exploding now, so probably have to do something, because it's reaching a state where it's not knowing how to deal with the mesh. We can increase obviously the bullet constraint, but I want to move on, and we need to set a few things up that may change the sim quite a bit. So let's go back here, and maybe let's set this to 1 so it's faster to work with. Just one block. Okay, and I'm gonna create an attribute. I at active equal 1, and then group some pieces from the pillar. Yep, and set those to be inactive. Okay. Cool. So we've done that, and then the next part I want to do is I want to break these the pin constraint. So I'm going to create a solver like we did before, and this is the constraint. Right now it's importing everything, and I don't want to process everything. I don't want to work on the glue. I don't want to touch that. So I'm going to use an a blast node to separate them. Okay. And I'm going to use if name or constraint name. Sorry. Constraint name is equal glue. I want to isolate them. So this is the glue. And if we inverse that, we get the pin constraint. And this is the parts that I want to affect. Okay, with the pin, I'm going to use the if at force is higher than, let's try it with 1,000. I want to change the constraint name to equal pin broken. And this is going to change few things. This is going to, I'm going to change this to pin, not glue. Okay, so this will be our pin, and then everything else, because this will include the pin broken next time. So okay, so this is the pin, and let's merge this with the other stuff. We don't want to delete it and leave it there, because that will just make it not work. At force, yeah, this will work once the first frame. You don't see any force or any attribute that are related to the sim. We have to run at least one frame for it to work. So if we hit play, it's too soft. Yeah, it's gonna bounce back. So another attribute that I like to use, apart from this, actually, you know what? I always forgot. You need to set this to a primitive attribute. Let's go back. Another attribute that is available with the pin constraint is the angle that tells you how far the pin got bent. So we can use that as well. I'm going to increase this to 12,000. And I highly encourage you guys to take a look at the other parameters available and see which one can be used to create some interesting behaviors. Cool. I'm going to increase the glue constraint. Actually, I'm going to set this to -1, and this way we can only the glue will never break. See? It's just the pin that is breaking now, and it's holding these guys. So the value is pretty cool. I'm just going to increase it a bit. See here? See this motion? That's very, very, very realistic. You get this feeling of something stuck together, and then it's all these guys are falling together. And another cool features that we get for free from all this is the clustering. Okay, because when you see a lot of time you see destruction, you feel like there is either pieces or debris, and with this workflow you will automatically get the mixture that you need to vary the sizes and everything, and getting these kind of blocks is very, very challenging. So, but with this workflow, hopefully you guys will be able to get some cool details. So let's increase this to 15,000, and I'm gonna increase the pin as well to 16,000. Hit play. I'd like to, the glue, I want to make it stronger. And I'm gonna set the propagation rate to 0, even though there's no, the clusters, the glue clusters are not connected together. Yeah, something like that. Let's make sure. I'm gonna create an output node. Make sure that this is what's being outputted. And it's just a matter of tweaking the values now. Yeah, we're getting there. So you'll get that nice breaking here, and then everything is falling down. Now, one thing to basically take this to the next step is what we can do. We can fracture the pieces even more. We do another level of fracturing. So we have these pieces now. We can increase the amount of pieces 4 times, and then we can create a glue cluster. Do this. Actually, I'll show you the workflow, the idea of the workflow. So I'm gonna create another glue cluster, something like this, but I want the pieces to be very, very small. Okay, and I'm gonna set this to -1, so these guys will never break. That means we get some clustering, we get groups of pieces that never breaks. I'm gonna copy these guys. I'm gonna glue strong or glue cluster. I'm gonna copy this name, and I'm gonna create another one here, glue constraint. I'm going to set the name to that, and then the force to -1. And this way, it will always hold whatever pieces that are together, even though they may be in between the pin constraint. We are holding them together forever. We can increase this, maybe something really high, in case we wanted to break it, even if there is a super strong force. But so far, when you look at it here, you get a lot of nice distribution, so that's very, very cool. I'm going to increase this to 80,000. And it's just a matter of tweaking these values and tweaking... let me explain a few more things. Yeah, so this is perfect. To me, getting this big block and all these guys, and they will still fracture as they go, as they still interact and everything, which is great. You get secondary fracturing almost for free. See that piece separated there, and it's still going. Look at that. So you get all the interesting behaviors from the system, which is another big factor. And this is why I wanted to it said that we don't need the interactive fracturing, because if we set it up correctly, as this object hits, it will lose pieces if the force is strong enough, and there is, yeah, so it came in as one piece, it hit the ground, and then it left all these guys behind it. See this block there, boom. Okay, so how can we control this? Well, the workflow goes like this. How much pieces do you have here defines the behavior, has a big impact on the behavior of the sim. Okay, so if we go back and increase the number of pieces by 4, we have to change quite a few things to get the motion to behave nicely. The next thing is how big the cluster and the pin constraint, how much balance do you have. If you have too much pin constraint, then the result is going to be very soft and may even fall without holding itself, and not being able to hold itself. If you have too much glue cluster, then it's going to look very very robotic, either 1 or 0. There is no in between. And then so number of pieces, the size of the cluster, which is in this case this guy, and or this. So this is a very small cluster. So this size is very important, and you can also layer another one on top of this. So for example, you found settings that you're happy with, you can create another glue cluster that has pin constraint as well, but has different values, so you can link the pieces differently, and you can set breaking rules differently in the stop solver. Okay, so let's go back here. I wanted to show one last thing with the sim. I did the delete here. We don't have to do it here. We don't have to separate the blocks like this. We can just do an if statement on here and say before the force, if s at constraint name equal to pin, execute the what's below. Okay, and then we don't have to worry about any of that stuff. So this will give us the exact same result. This condition will only be executed if the constraint name is equal to pin. Let's go back up and let's turn this to 0. Okay, and let's create a dot import. I'm going to drag this in here, copy this name, paste it here, fetch, create points to represent geometry, and let's go back inside the solver. And for final, I generally don't have to change these guys. If you have collision issues, sometimes changing the padding under the bullet data to 0.1, and this half of that, 0.005, helps. Something like that. And then for the final settings, I would go to 20 on both of these guys. You can go up to 40, maybe 25 here. Make sure that you have split impulse. There's the two method for parallelizing the graph. I generally use this. You can try different. You can try the second one. It's a way to parallelize the processing of the constraints. Sometimes turning this on, the randomized constraint order, helps stabilize the system because it doesn't solve the same constraint over and over, and that helps relieve stress on the system. So let's hit play, and this is running on an i7 that has 6 cores, so it's quite old machine. You can see it's running almost real time with all these pieces. Now the next thing, I probably want to pin this part here. And have those pieces stay hanging on in the air, because it doesn't make sense for them to be there and not be there in the next frame. So let's let this run for a couple of frames. I'm actually pretty happy with the stability of the system. This is behaving much better than the one I made. Cool. Let's go back up and dop import, and let's object merge this guy. and use the transform pieces. Come on. Sometimes the transform pieces can give you weird result, and what helps is to provide the rest positions. So we can use a time shift and define a rest position, which is in this case frame 1, and plug that in. This helps stabilize if you see weird behavior happening to the mesh. You can use that. Okay, let's play this and see what we get. Just 100 frames. Cool. So the next thing we're going to look at is having an impact force from within the sim. Right now we have the sphere hitting the system, hitting the RBD sim, which is great, but we want to create something within the sim that pushes the pieces from inside. And this type of source is very different. This type of force is very different, and we may have to go back and readjust various things in the forces that we set to break these rules. Cool, we don't have the sphere visible. That's fine. Cool, so I'm pretty happy with the result. We'll continue in the next video and add the custom forces. Thank you guys for watching, and see you in a bit.